again, the mode is in degree mode. And I have the inverse function of sine applied to 1/3. The answer should be in degrees. 19.47. Good. So if this is 19.47 degrees, I will subtract this from 90 degrees to determine A. So then I do this. I'll say 90 minus the previous answer, 70.53. So angle A is 70.53 degrees. Any questions on this? Any questions? Good. Let's continue with one more. On page 9.
Could you show that last page real quick? I'm sorry.
Of course. Of course, my pleasure.
Is that a 4 or a 9 next to the 7 and 19?
Yeah, it's 4. I'm sorry. 4. Is that better?
Yes, thank you.
Perfect.
I'm all good now.
Good, excellent. Thank you. So let's look at one more. And when we review for the test, we'll look at more. But let's look at one more. Let's say this one. The angle of inclination from the base of the John Hancock Center to the top of the main structure of the Willis Tower is approximately 10.3 degrees. So my understanding for this is, okay, so this is the John Hancock Center, and here is the Willis Center, or Willis Tower. And it says that this angle is 10.3 degrees. So this is my understanding. Let's see. If this is the John Hancock Center from the base till the top of the Willis Tower, this angle is 10.3 degrees. Let's read it again. The angle of inclination from the base to the top is approximately 10.3. If the main structure of the Willis Tower is 1450, so this height is 1450 feet. How far apart are the two skyscrapers? Assume the bases of the two buildings are at the same elevation. Okay. So they want us to determine this. We have this height, and they want us to determine this distance. Any suggestions? How should we find the distance? We'll call it x. Is there any trig function that we can apply right away? Any trig function that we can apply right away?
Tangent.
Very good, excellent. So we have tangent of 10.3 degrees equals opposite leg over the adjacent leg, 1450 over x. Remember, it's a proportion. X equals 1450 over tangent 10.3 degrees. Again, make sure that you have the calculator in degree mode. 1450 divided by, here's tangent 10.3 degrees. And that is x equals 7978.83 feet. 7,978.83 feet. Meaning the distance between the two buildings was determined using a very simple a trig function. Tangent of 10.3 degrees, opposite over the adjacent. Excellent. Okay, moving on to 7.2 and 7.3 laws of sine and cosine. What does that mean? What does it say? Okay, let's talk about it and then we'll look at applications. We no longer, when we talk about the law of sines and law of cosines, we do not talk about right triangles. In any triangle. Okay, so let's say I have this triangle, ABC, obviously mandatory, carved in stone, A, B, C. The law of sines states that in any triangle, including right triangle, by the way, in any triangle, the following will always happen. Sine A, again, just to make sure, the opposite of A has to be denoted by A, the opposite of B, because for some reason I wrote C, I don't know why. So the opposite of B has to be denoted by B, the opposite of C has to be denoted by C. So then, law of sines says, sine angle A divided by A must equal sine angle B divided by B must equal sine angle C divided by C. So maybe I should make this a little smaller c. So sine C over C. This is law of sines. What about law of cosines? So this is law of sines. So this is 7.2 and law of sines is 7.3. Law of cosines is 7.3, but I would like to present them together. So see, here's the law of cosines. I'm going to draw the triangle again. A opposite A, B opposite lowercase b, C opposite lowercase c. Same triangle, of course. A squared equals B squared plus C squared. And you can say, but what are you doing? You cannot, and I cannot stop here, but this is the Pythagorean theorem. Minus 2BC cosine A. Of course, the angle, right? Also, B squared equals A squared plus C squared minus 2AC cosine B. And of course, there is a third one. They're all the same. C squared equals A squared plus B squared minus 2AB cosine C. And yes, this is the Pythagorean theorem if A or B or C respectively are 90 degrees, because this is 0. Cosine 90, cosine 90, cosine 90, 0. And I recover the Pythagorean theorem. In some books, you're going to find this not called the law of cosines, but the generalized Pythagorean theorem. So this, we're going to call it law of cosines. But please remember, it's the Pythagorean theorem for the general case. So in other books, the generalized Pythagorean theorem. Why? Again, if the angle is 90 degrees, cosine is 0, and we get back to the Pythagorean theorem. Okay, so before we apply these laws in different applications, I need to mention the possible cases. So we understand possible situations or cases. There are four possible cases. And here they are. 1. Angle, side, angle. Angle, side, angle. Side, angle, angle. They're the same case, basically. Side, angle, angle. What is this? What am I talking about? Okay, I'll get back to the others in a minute. What is angle, side, angle? It means that I'm given an angle, the side, and the angle. This is angle, side, angle. What does side, angle mean? A side, an angle, and an angle. This is side, angle, angle. So what does this mean again? I am given an angle, the side, and another angle, and I'm asked to find this side, and this angle. What does this mean? I'm given a side and two angles, and I'm asked to find this side, and this angle. That's what this is all about. Now, this case has two options. Two options. Yes, never. What does this mean? I'm given the information and I can find the angle. Or I'm given the information and I say, wait a minute, that's not possible. Whatever you gave me does not build a triangle. So this option, angle, side, angle, can exist or not. Side angle, angle can exist or not. Why am I writing this distinction? In a minute, you'll understand why. So this is the first possible case. The second possible case, side, angle. What does it mean? I'm given a side, and I'm given the angle in this order. Or here, side, angle, it doesn't matter. But two sides and the angle, side, angle. What are the options here? Well, this one is the only one that has three options. Yes, never, two cases. Or two, in other words, two triangles are possible. This is called the ambiguous case. This is the only one that may give us trouble. It exists? No, it does not exist. Or there are two triangles that fit the information given to us. It's called the ambiguous case. And it's the only one. It exists, it does not, or two options. Two triangles fit the information. There are two more cases, which is side, angle, side. And number 4, side, side. Side, angle, side means side, angle, and side. Of course, side, side, side means side, 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 and no angles. This only law of cosines. If I'm not given any angle, I cannot apply law of sines. Something has to be given to us. Some angle has to be given to us for law of sines to be applicable. This one, I can be given all three sides, and I can determine angle. Okay, so let's see how this works. We will see the situations, and we will work on anything we want. Okay, so I'm sharing now, and here is, where is my law of sines? Okay, I can close this up. Okay, so solve each triangle. We are given two angles, and we're asked to solve and a side, and we're asked to find the other angle and two sides. We are given two sides and an angle, and we're asked to find everything else, two sides and an angle, two sides and an angle, two sides and an angle. Is this the same? No, it's not the same. And then a couple of word problems, 3 word problems. Okay, so let's start. So let's start with the first one, and then we'll move on to the rest, and you choose. So let's start with 20. So they say angle A is 70 degrees, angle B is 60 degrees, and side C is 4. Okay, perfect. Allow me to start a new video.